Welcome and hello. This is a video exercise on HEC ResSim. And in this exercise, I'm going to be discussing downstream control rules. All right, so what I have on the screen here is an instance of HEC ResSim version 3.3, and I'm starting in the watershed setup module. Let's go ahead and start from the beginning with every single click and keystroke narrated to hopefully help you follow along. All right, so I'm going to go File and New Watershed. I'm going to give my watershed a name. It'll be called Video 10, and then select the location for the directory you want your watershed directory to be created in, and then the units and the time zone, apply, and OK. So just click OK enough times, and we have our watershed created. Okay, so next I'm going to click this stream alignment tool, and let me zoom in a little bit first. And then I'm going to hold down control key and then single left click to start my stream. I'm going to hold down control key, just keep it held down the whole time, and then just sketch out a stream alignment here. And then before the last click, let go control and then a single left click, give your stream a name. So this is my main stream. I'm actually going to go ahead and with the stream alignment tool still selected, trace in a tributary. So I'm going to hold down control to start, single left click, and then just keep holding control down, and then I'm going to click right there. I'll call it stream 2. It's going to prompt me asking if I want it to connect to stream 1. The answer is yes. Now I'm going to click the computation tool and hold down the control key, single left click, and then let me just type in CP1 as its name. I'm going to select the reservoir and then hold down control, single left click, let go of control, and then I will click right here to represent the downstream of the reservoir pool, which is the location of the dam face. Call it reservoir 1. This will be our only reservoir. If you want to zoom in and sketch the reservoir, you can double click and then reposition the name and then hold on to the vertex here and then kind of give it some new shapes. If you want to add a vertex, you hold down control, and more details like that are available in the lessons. So that's cool. All right, let's add a few more computation points and then get on to our configuration. So let's see here. The computation point tool, I'll hit add one here. I'll call it CP4. And then let's do one at the junction. So I hold down control, I click at the junction. I'll call that CP5. Okay. And oops, hold on. I'm going to delete CP5 real quick and then add it back in. What I what I need to do is specify that it's at the junction. It asks if it's on stream 1, stream 2, or at the junction, or none. So I want it to be at the junction. Okay, let me type in CP5 again. And then let's see, down here, I'll say CP6. And then the ups on the tributary here, I'm going to add one, and we'll just call this CP7. Okay, so that's good. I'm going to click Watershed Configuration Editor. And here I'm going to click Configuration, New. Give the new configuration a name of config1, and we'll say the time step is 1 hour. Okay, and then Apply. We'll load our configuration 1 up here, and we are good to go on the watershed setup module. So I'm going to go ahead and File, Save Watershed, and then we'll head over to the Reservoir Network module. Now, before our junctions and the reservoir pop into place, we need to create a network based on that configuration. So I select config 1. Now we'll give it a name. We'll just create it right now, calling it network 1. And then here is our network. Now we need to connect the network with the reach tool. So I select the reach tool, hold down control on the upstream junction, let go of control, and then single left click on the next adjacent downstream junction for that particular reach. It gives me a suggested name here, and that's fine. I'm just going to click OK, and then repeat that process for all the other reaches in the network. Now let's go ahead and set a inflow for CP1 and CP7. These are the upstream most junctions for their particular reach. So to do that, I'll select the junction tool and then click right click, edit junction properties, and then select the local flow tab. And I'm just going to call this inflow at CP1. This is the main branch. The factor will be 1, and then click apply. This doesn't actually tell us how many cubic feet per second over what duration, but what it does is it's telling the alternative editor that it's going to expect a time series associated with this junction. So just keep that in mind. We'll be getting to that in just a bit. Okay, let me switch to CP7. Remember, that's this upstream most junction here. I'm just going to call it inflow at CP7. And then again, a factor of 1 to keep things simple. Apply and OK. Before we move on to the reservoir geometry and zones and rules and all that, let's keep with that inflow idea since it's fresh in our mind. So what I want to do for this simulation in this exercise is to create a downstream control rule that's predicated in looking at this CP6, this downstream most junction. And I want to give it inflow from CP1 and CP7, the upstream junction. Now, CP1 obviously routes down through the reservoir one, and CP7 routes down through no reservoirs whatsoever. So what I want to do is first induce a shortage with, I'll have a demand down here of 5,000 CFS minimum, and I will only give it 4,000 CFS at the upstream junction, and I will send it with zero, I will say zero inflow at CP7 here on the tributary. And then I'm going to modify it to give CP7 some flows, and we'll see how that downstream control rule works at our reservoir one. All right, so that's kind of a roadmap of where we're going with this exercise. Let's do what I said and start with creating those time series data sets. So you can go to Tools, HEC, DSS View. And what I've noticed is that this interface doesn't quite have all the features that the standalone HEC DSS View software does. So what I'm going to do is just open that up. Okay, so I got HEC DSS View opened up here. I'm going to go ahead and create a .dss file, time series data.dss, and create. Okay, and the file is created. I'm going to start by data entry, manual time series. Now let me type in some path name parts here. I'll just be generic and call it project, location, flow, and then the user defined term will be 4,000. This simulation is going to be for the month of January 2024. So I'm going to say 01 Jan 2024 at the first hour. The units will be in CFS, and then the type of instantaneous value is fine. All right, next I'm going to click the automatic generation tab, and then the end date is going to be the last day of the month, and it's going to have a time of 2,400 hours, and then a fill value. This is the actual flow now is going to be 4,000 CFS. So if I tab off of that, generate, I'll have my records showing up here. It's 744 hours of a constant 4,000 CFS. So go ahead and click save. I don't need to revisit the edit screen. Now I wanted to create a couple other time series data sets, and it's actually easier to just duplicate this data set, rename it, and then edit some of the values. So I'm going to create a constant 0 CFS time series data set. Now that may seem kind of silly because why have a data set at all? But I believe ResSim gets a little cranky if you say there's going to be a time series at a junction and then you don't actually give it anything. So there, I've renamed it. Let's go ahead and right click. Sorry, you got to select it first and then right click edit. You can also come up to this edit button here or tabulate. I'm sorry. Yeah, this is to view only, but you can edit from the screen if you select edit, allow editing. So similar deal. All right, so I'm just going to type in a 0 at the top record. And then instead of typing 0 again for another 743 times, I'm going to just hold down the shift button and then hold down the page down button. It'll take me to the bottom and I'm there. I'll continue to hold down shift, but then let go of page down and then arrow up a couple times. So I'm on the last record and then right click, fill. And I want repeat fill. So that's going to take the first record and then copy it down for all the highlighted records and click OK. So that's what we have here. All right, so I'm just going to file, save, OK. Now what I want to do is create one more time series data set, and it's going to start at 0. After a few days, it's going to pop up to 4,000 CFS, and then it's going to go back down to 0 CFS. So let's make a duplicate of that 0 CFS time series data set. Go duplicate, and then I'm going to name it 0 4000 0. Tab off, OK. It's been created. I'm going to right click and edit. Okay, so here's that. Now let's wait a few days into the simulation to actually start the increased flows. In fact, let's come out to, how about January 7th? So January 7th, let's actually make let's call it 4,000. And then let's say it starts increasing from 0 up to 4,000 on January 6th. So where's January 6th? Here's the first hour. So what I'm going to do, it's 0 is the value now, and that's fine. I'm going to highlight those values and do a linear interpolation fill. So what that'll do is look at the first value and the second value, and then just linear interpolate by updating the intermediate values accordingly. Right click, fill, linear fill, okay. So now we can see a constant increase from 0 to 4,000. Let's say the flow remains at 4,000 for 24 hours, and then it decreases down to 0 again. So let's see, 4,000. We need to fill these in. So here, here, fill, repeat. And now we're going to do one more day of the descending limb of this, what is kind of an artificial hydrograph. It's just kind of a trapezoidal hydrograph. And let's see, am I off an hour? That doesn't matter. Okay, fill and then linear fill and then okay. Let's file, save that, and then let's view all three of these time series data sets together, just so we can see what we're looking at and what we've created. I'm going to zoom in here on sort of our area of interest. And so here's in green our bottom one. This is the 0 CFS. This is the 4,000 constant CFS. And then in red is the last one we created that goes from 0 to 4,000, waits there for a day, and then back to 0. Okay, enough of DSS view. We have our time series data sets saved, and we will bring those in once we're ready to create our alternative. We're back at ResSim now, and it's time to make some modifications to the reservoir. We need to define the pool and the rules and the zones and all that. So I'm going to go click Edit Reservoir Properties. I like to rename the dam to just dam. And then let's click on the pool. This is where we specify the reservoir geometry. Okay, I'm pasting in the records here. So we have a total of 50,000 acre feet. I'm going to set the guide curve to an elevation of 1480, even though the top of the dam is 1500. So keep that in mind once we get over to the operations tab. All right, so that is all we need for the pool. If I click on the dam, now we'll type in that top elevation of 1500. I'm just going to make up a length across the dam. And then let's add a controlled outlet with plenty of capacity so that isn't a factor in the simulation. Okay, I'm pasting in some data for our controlled outlet, and let's just make it 3 gates so there's plenty of capacity to release as much water as needed. We'll go ahead and click Apply. All right, now let's head over to the Operations tab. This is where we create the operation set and the zones and rules and so on. Operations, new. I'm going to call it Operation Set 1. And the default zones here load into place in the zone rule tree. Over to the left, we have the flood control zone, the conservation zone, and the inactive zone. So let me go ahead and type in some elevations representing the top of that zone. Apply conservation. I said 1480. And then inactive will be the bottom. That'll be 1350. Okay, apply. So if I double click the plot, we have inactive zone, which really doesn't exist because that's the bottom of the reservoir pool. Here's the conservation zone, and then here is the flood control zone. You know, it may look a little deceiving because the conservation zone is actually about 29,000 acre feet of volume, and then the flood control zone is about 22,000 acre feet of volume. So it looks like the the conservation zone is much larger, but it's only a little bit larger, maybe on the as far as ratios go, three to two. All right, just something to kind of keep in mind when thinking about elevations versus storage. All right, as you can see, highlighted in bold is conservation. That means this particular zone is the guide curve zone, and it's 1480. So we're going to start our simulation with the water surface elevation at that 1480 foot guide curve elevation. All right, next I want to do is create a rule. Now, as the exercise title suggests, this is about a downstream control rule. I'm going to move this to the side so I can see the plot a little better, or see our diagram. Add new rule, and I'm going to call this downstream control at CP6. That's this junction right down here. Okay. Downstream control rules only work on the reservoir, so I'll select reservoir and then downstream control. Now we have to specify the downstream control element, and that is CP6 junction. There's junctions and reaches, but you'll most likely be selecting a junction. Okay, let's go ahead and add that rule to all the zones. That looks good. Now we have to define what that rule is. So it's going to be a minimum flow. So we'll select minimum, and it's flow, so that's good. And it's CP6, and we want it to be 5,000 CFS, and it's just going to be a constant 5,000. So I'll click define. We'll just use date. That's the default selection here. And we'll just type in 5,000 here, which will apply for all 12 months of the year. All right, that looks good. Now it's time to save that, and we'll go ahead and create an alternative. So let's go alternative, edit, and then we'll go alternative new. I'm just going to call it a base case. It's alternative one, I guess. That's fine. Okay. For time step, we'll say it's 1 hour. The operation set is the operation set we defined previously. The look back tab is where we identify some of the initial conditions for that look back period. So the elevation I said would be the 1480 guide curve elevation. And then the release is going to be 5,000 because that is the minimum release dictated by that downstream control rule. And let's go ahead and hit save. And oh yeah, the time series tab, good to include that. So CP1, this is going to be our 4,000 CFS, the constant flow. So let me navigate to that directory. Okay, there's 4,000 and set path name. So that's set in there. And then CP7, this is our tributary. We actually want it to start at 0 CFS. So let's go ahead and select 0 and then select set path name button. That populates over here. Let me save that alternative, and then we'll head over to the simulation tab. So network, save, and then simulation module, the simulation module. All right, let's create a new simulation here. I'll call it simulation 1. The start date and the end date now will be January of 2024. The look back period, I'll start it on January 1, and that will be the first hour of the month. And then for the start date time, I'll say it's January 2024 at noon. That works. And then the end of the simulation will be January 24 at noon as well. Okay, so select our alternative and then click OK. All right, great. So the network pops into view here. We have the simulation tree over to the right, and we are ready to run the compute. So I'll click that button, click close. All right, let's see what happens here. Let's right click on the reservoir and then click plot. I'm going to make this full screen here. So I made this full screen. And what we can see here is our reservoir has a constant 4,000 CFS of inflow. And the outflow from the reservoir is in green here, and it's 5,000 CFS because of that downstream minimum release requirement. And what we see here is 15 days into the simulation, the flow rate decreases back down to 4,000 CFS. and that coincides with the same time that the water surface elevation in the reservoir drops down to what is probably its minimum release at 4,000 CFS. So basically the reservoir ran out of water. It's already operating at a deficit of 1,000 CFS here, 5,000 minus 4,000 for half a month almost, and finally couldn't keep up. It ran out of water. All right, so that's a good base case. What I want to do now is add a trial to this alternative. And what we're going to do is, instead of a zero flow coming from the tributary here at CP7, is assign that time series data set that gives us extra water. And we're going to see how that affects the flow in the reservoir, the operations, and then also down here at the junction, which we should probably check out as well. Okay, this is actually pretty good. Okay, so I made it full screen here. So it starts at 5,000 CFS and then it drops down to 4,000 CFS halfway through the month based on the outflow, the release from the reservoir. And then you can see the minimum downstream flow requirement is kind of a lighter green dashed line with some hatching down here, which represents the minimum flow requirement for this duration. So let's go back to the simulation module and then come over to here to alternative, and I'm going to go right click new trial. So what this does is it's asking me to name the new trial. The trial here is basically a copy of the alternative and allows me to make modifications to that alternative, run a new compute on the trial, and then see how it compares to the alternative. And if I really like it, I can actually adopt those changes into the original alternative. So let's go ahead and give it a name first. I'm going to call it 0-4000-0. So that's the CP7 inflow. I could add that to the name of the trial, but it's all right. So I'm going to go ahead and click OK. Now to make edits to that trial, we're going to right click, edit run. Now I'm going to select reservoirs, junction, reaches, diversion, anything that I want to actually modify about this trial. So what I want to change is the inflow time series. That's part of the alternative editor. So I'll click the time series and then select that CP7 inflow record, click the select DSS path button, and then I'm going to come over here and select this record. This is the one we want. I'll click set path name so it updates over here. And then I'm going to go and click save the alternative. Even though it's a trial of an alternative, I think I have to save it anyway. Okay, let's go ahead and click OK and then right click compute. And that would be the same thing as clicking compute down here. Okay, so compute. And something didn't work. I had a feeling this would happen. This is the correct path name, but ResSim is looking in this RSS directory for the DSS file, and that's wrong. Okay, what I'm going to do is open up that DSS file we created earlier in the exercise. Here it is. Here's our 3 time series data sets. I'm just going to select them all and go edit, copy to, and I'm going to send it to that directory that HEC ResSim is looking for it in, which is in the RSS directory, and then the simulation directory, and then simulation.dss. Okay, open, which is really a copy. It's asking me if I'm sure I want to overwrite. Yes, and then give it a moment. Okay, so the records were copied over. That's good. Now, when I'm going to edit alternative editor, I need to select this time series. So select. Now, this is not the file that was working for me before. So I'm going to navigate to that file I just copied the records to. So we're in the watershed directory, RSS, simulation 1, and then here is the .dss file we want. Open. All right. Let me just use the filter to find the time series I want. This is it. And then set path name. Okay. So that updated it here. Now it should work. Save that. Then close. Okay. And then right click compute. All right. So that looks successful. Let's go ahead and check out the results. Let's start with the downstream flow. So we have a requirement of 5,000. Oops. Hold on. Let me uncheck the previous results. So we're only looking at the last compute results here and then plot. Okay, so I made it full screen here, and this is interesting. Again, we have a 5,000 CFS demand, and it looks like that demand was met for all the way till January 22. Early afternoon is when it actually ran out of water, which makes sense because without that additional inflow, we ran out of water a number of days earlier. And there's also a peak in that flow towards the end of the hydrograph here, kind of on January 8th. So that's interesting. Let's go ahead and look at the reservoir. I think that'll help us explain what's going on. I'm going to go right click and then plot. And then what we're seeing on the screen here is the plot of the reservoir during that January simulation. So on the top, we have the elevation of the water surface in the reservoir pool. It starts at 1480 because that's our guide curve elevation. And then it drops because for the first 5 days, we have a deficit. Our inflow is a constant 4,000 still. Remember, this is just the the west branch, the main branch with a constant 4,000 CFS. So it's not seeing that new artificial hydrograph that starts at 0, goes up to 4,000, and then back down to 0. This is only the constant 4,000 CFS. And then the release from the reservoir is shown down here in the bottom plot in green. So it's releasing 1,000 CFS more than the inflow, and that's why the water surface elevation is dropping here for the first 5 days. And then what's happening is interesting. The release drops from 5,000 down to 1,000, and this corresponds to the increase of 0 CFS up to 4 CFS from the tributary, because remember, it takes place over the course of a 24-hour period. So that's why we're seeing this linear drop from 5,000 to 1,000. And this is really the whole purpose of using downstream control rules. They're really just release function rules, but a little bit fancier because it can look at other parts of the network and correspond to satisfy downstream flow requirements or stage requirements, such as what we're doing here at junction CP6. All right, so the 7th day of January is constant. This is where we have 4,000 CFS of flow from the tributary and 1,000 release from the reservoir, which is the main branch. And then after that, this may be a little bit hard to understand at first. Let me zoom in, actually. Yeah, this took me a while to understand. What happened was you can see a straight line, and if we just continue that straight line, it would continue to match this straight line right here. So as the water from the tributary decreases from 4,000 to 0 CFS, then you would expect the water in the reservoir release to increase from 1,000 back up to 5,000. And that would be the case if we just drew a straight line here. But the reason why we have an instantaneous release, or what seems it just kind of goes off course and goes straight up to 4,000 immediately, is because at that time, the water surface elevation in the reservoir reaches its guide curve elevation of 1480. So it doesn't want to go over 1480. And that's where the priority of satisfying that guide curve elevation comes into play, because there's no penalty to releasing more than 5,000 CFS at that downstream junction CP6. All right, so that's cool. The only thing I want to do now to modify this simulation is to start the reservoir with less water. So if we start it with, say, instead of 1480, we start with 1460, but we keep the guide curve elevation at 1480, then I have a feeling that we will see this line connect because the water surface elevation will never actually achieve that guide curve elevation of 1480. Let's go ahead and do that and then see what happens. So I'm back in the simulation module, and I'm going to right click on our trial and create a new trial based on that trial. So this is going to say 0-4000-0, and I'm going to call this 1460 as the starting water surface elevation. And in fact, it may make sense to rename trial 1 to specify that trial 1 starts at 1480, just to add a little bit of a distinction there. So I'll go rename trial. This will be 1480, water surface elevation, initial. If I wanted to be complete, I would fill out the description and add a little bit more information, but this is good for now. So I'm going to go ahead and edit. And then we want to change the look back information, which is in the alternative editor. Here's that tab. Instead of 1480, I'm going to go 1460. Okay, so I'm going to say alternative save, which is really a trial save, but close enough. And then OK, and then OK. All right, so let's go ahead and compute and then click close. Now let's take a look at the flow at our downstream junction 6. So what happened here was we have a flow of 5,000 CFS. It's satisfied for what, 17 days? So it's not quite as long as before with where it was like 21 days, I believe. That makes sense because there's less water in the reservoir to start the simulation. So we wouldn't expect that downstream flow requirement to be satisfied as long. All right, let's check out the reservoir now and click plot. Okay, so here's the plot, and this is indeed what I expected to see. We have our release from the reservoir, just like last time, except because the guide curve elevation in the reservoir is never achieved, it doesn't want to release any extra water like we saw in the previous trial. Let me turn the results on for that previous trial. Plot. All right, so here we have both trial 1 and trial 2. In red, that's bold line here, is our trial 2 data, where the water surface elevation begins here at 1460. And then in green is the trial 1, where the water surface elevation began at 1480 and then was reachieved at 1480 momentarily until the tributary inflow decreased to 0 again, in which case deficits were incurred. All right, so this was an example exercise in HEC ResSim describing the downstream control rules and then running through an alternative and a couple different trials and looking at these plots to better understand how water managers use HEC ResSim to model their system.